So now that we know exactly what acceleration is, in this video we're going to talk about how to use acceleration to calculate where an object is actually going to end up after a given amount of time. But before I begin talking about what the equations actually are, we need to talk about what the variables are going to be that actually go into the equations. So I give you the 5 variables of awesomeness, and these will get you through the majority of early level physics problems. The 5 variables that you're going to use in the early part of physics to describe an object's motion are VI, VF, A, T, and delta x. VI and VF are pretty simple. They're just telling you the initial velocity of the object, so how fast it was going at the beginning of the problem, and the final velocity of the object, how fast it was going at the end. Be careful with negatives, though. If an object is going the opposite way, you must put a negative on it. A stands for acceleration. Just watch the last video if you want more explanation on what that is. T stands for time, just the amount of time that went by while the problem was taking place, while the object was actually moving. And delta x stands for displacement, which is a fancy physics way of saying how far the object got from where it started. It's not necessarily how far the object traveled, but it's how far it ended up. If you were to put a mark where it started and put a mark where it ended, it's how far away those two are. And be careful, because delta x can also be negative. If you end up behind the location where you started, that would be a negative delta x. One of the biggest mistakes I see in my class, so be very careful with this. And we'll do some examples later on where you'll see it in action. So here are the equations of awesomeness that tell you what in the world you're going to do with these variables. We've already covered this one. Acceleration equals final velocity minus initial velocity divided by time. How much faster or slower you got divided by how long it took. The second equation is delta x equals 1/2 at squared plus VIT. You're going to really want to memorize this one because this one ends up getting used a lot. Basically, if you want to know how far something goes and you know its acceleration and the amount of time that it's spent accelerating, this is going to be your guy. The third big equation is final velocity squared minus initial velocity squared equals 2 times acceleration times displacement, delta x. The 3 equations that I have listed in yellow are going to be very important to you, and you'll probably want to memorize them because you're going to use them so much that you're going to end up memorizing them anyway. However, there's also these extra 2 that I like to call ninja equations. You do not have to know these 2 at the bottom. You can get away with just knowing the 3 up here. But if you know these 2 on the bottom, sometimes you can solve the problems a little bit quicker. Every once in a while, these will work as a shortcut. So if you're feeling like a smarty pants, then you'll probably want to grab these equations down here as well. So I know this might look like a lot of information, but it turns out a lot of the problems that you're probably going to have to do in your class are going to pretty much only involve the information right here. If you are a master of the information here, you're going to be in really good shape for a pretty good chunk of physics class. And let me show you a sample problem of these things in action. So as a sample problem, we have a car that starts from rest and it accelerates at 2 meters per second per second. How far does it go after 5 seconds of accelerating? First, on a problem like this, we're setting up our variables of awesomeness. So I redrew the chart down here, and it's just a matter of filling in the values that the problem gave you. So just by reading the problem, I was able to figure out that the starting velocity was 0, acceleration was 2, time was 5, and we don't know these 2 values. That's what we're looking for. Step 2 is to look at your equations up here and see if you can find an equation that figures out the thing that you're looking for and also includes all the stuff that you already know. In this case, it's this equation that's going to do the trick because it has delta x, a, t, and vi, and we know all of those except for delta x. If I write the equation and fill in everything we know, I end up with this. And for your final answer, we get that the car went 25 meters.